An inequality has an infinite number of solutions. If I tell you I'm going to eat more than 5 tacos, I could eat 6 tacos, or 7 tacos, or 10.5 tacos, or 53 tacos. In other words, x is greater than 5 has an infinite number of solutions, an infinite number of values that make the statement true. The graph of an inequality, which takes place on a number line, represents all of those infinite values. Let's look at our first example. A is greater than or equal to 3. Let's think of some of the possible solutions to A is greater than or equal to 3. Well, 3 is 1, because 3 is greater than or equal to 3. 3 equals 3. 4 is greater than or equal to 3. 5 is greater than or equal to 3. So is 6, 7, 8, 10, 13, and then all of the values in between. 3.5, 4.25, 5.1. However, this is not how we graph an inequality, by sitting here for the rest of our lives plotting the infinite number of values greater than or equal to 3. The way we graph an inequality is with a big dot on that starting value, 3. We call this a closed dot because it's filled in, and 3 is part of our solution. 3 is greater than or equal to 3. And then an arrow to the right indicating all of the values bigger than 3, 4, 5, 5.5, and so on. We have a closed dot right here, closed dot. This is a closed dot for less than or equal to or greater than or equal to symbols. That's because of the equal to component. When there's an equal sign, that value 3, that starting value, is part of the solution. Second example will be with an open dot. An open dot means not filled in. Y is less than -2 does not include -2 in the solution. -2 is not less than -2. This open dot is like a hole right over -2, showing that -2 is not included. What are some of the solutions less than -2? Well, -3, -4, -5, -10, -20, -2.5. Those little dots that I just did help me understand the inequality, but that's not my graph. My graph is an open dot at -2 and then an arrow to the left. Again, this arrow represents the infinite number of solutions to the inequality, the infinite values that make this statement true. G is greater than -4. Again, in this case, I will have an open dot. An open dot is when it's just less than or greater than. When there's no equals to component, -4 is not part of my solution. So I have an open dot at -4. But every value bigger than -4 is a solution. So here I'm just going to do an arrow to the right. So -3, -2, 2, 5, 1,000. Last example, I'm back to a closed dot since I have that equal to component. K is less than or equal to 0. So closed dot, less than or equal to means the smaller values headed in this direction. Hopefully your arrows are prettier than mine. What I would like you to notice is that as long as this variable is on the left and the value, the numbers on the right, my inequality symbol matches up with my arrow. So greater than matches with my arrow, less than matches with my arrow, greater than matches with my arrow, less than matches with my arrow. This has to have the variable on the left to work, however. So the inequality statement tells you the direction of the arrow. Equal sign, closed dot, no equal sign, open dot.